Did you get a? All right. Let me clarify how this whole course is working, because we have two classes at one time. All of chapter 1 you do under the DMAT. The introductory parts of each chapter you do under DMAT. The rest of the chapter you do under math, the 13, 14. So like chapter 2, section 1, we did under DMAT. Section 2, 4, and 5, we did under math. Chapter 3, section 1, DMAT. All the rest of chapter 3. Chapter 4, section 1, DMAT. The rest of chapter 4 here. So that's how the homework is done. And then chapter 2, section 3, chapter 5, section 1, the rest of chapter 5, and then chapter 6, section 1, and the rest of chapter 6. I should put that in the beginning of the course so we know what we're doing. Because I have to give progress reports today. So what don't worry about what it says. If it says you're doing horrible bad because you only did one part, then don't worry about it. There's still lots of time to catch up. Remember, everything's due by December 7th. So if you haven't even started chapter 1 yet, I'll just give you a little note saying, okay, you're falling behind, please catch up. And that'll be it. So it's not a grade, it's just I have to fill out this paperwork. So don't take it to heart. It's just I have to put something so it shows that I'm looking at your grades. So this, again, all these are the rest of chapter. So introductory parts, DMAT, everything else is there. We talked about chapter 1, section 1 and 2 last time. Talk about functions, what functions are, and the operations of functions, on how to add, subtract, multiply, divide functions. Now we're moving on to the last 2 sections of this chapter, symmetry and transform. So did we discuss the algebra of functions last week? Adding, subtracting, multiplying. If I had 2 functions and I add them together, did we talk about that? Okay, talked a lot. So we're just going to finish the chapter. Section 4, symmetry. What does symmetry mean? And something symmetric, what does that mean? It means it's a mirror image. For example, if you look at any of these 2 tiles in the ceiling next to each other, left to right or up and down, they're copies of each other. They look identical to each other. And that's what a symmetry talk about. When something's symmetric, it's that. Can you think of anything else that's symmetric? A circle is symmetric, yes. A triangle, if you cut it down the middle, it's symmetric. A butterfly, if you don't cut it, but look at it, it's symmetric down the middle. If you ever see a reflection off a lake and you see the same image top and bottom, that's symmetry. That's a horizontal symmetry. So that's what we're going to talk about today. When we say the word about, when we say something is symmetric about, that's in reference to. So X is symmetric about the Y-axis. So what does that phrase tell you? Or if I say f of x is symmetric about the y-axis. What does that tell you? Where's the mirror image? Is it horizontally or vertically? Horizontally. Because if it's symmetric about the y-axis is vertical. So if I have a point here, that means there has to be a mirror point here. It's symmetric about the y-axis. So let's look at how that works. If I have a point here at 3, 2, what would be the symmetric point about the y-axis on the other side? What would be that location? Very good. If I had a point at 1, 1, what is its symmetric point? Negative 1, 1. Very good. So how do we test for symmetry on the y-axis, about the y-axis? If the y values are the same, and the x values have the same number, but opposite signs, then it's symmetric about the y-axis. How would we represent that? X, y, negative x, y. That's what it looks like. If the y values are the same and the x's are the same number but different signs, then it's symmetric about the y-axis. Now, how does that work mathematically? Let's say I had a function, x squared plus 2. Is this function symmetric about the y-axis? How would you test it? To test symmetry about the y-axis, you're given a function, of course. Choose any number. For x. And plug it into f of x. So what number x you pick? What's that? No, pick a number. Okay, we're saying for our example, we're saying x equals 2. So we have f of 2 equals 2 squared plus 2. 2 squared is 4 plus 2 is 6. So f of 2 is 6. Second step. Plug the negative of that x into f of x, into the function. So since we used x equals 2 here, we're now going to use x equals negative 2. All we do is change the sign. So we have negative 2 squared plus 2. Negative 2 squared is what? Positive 4 plus 2 equals 6. If you get the same answer, then the function is symmetric about the y-axis. So we had f of 2 equals 6, f of negative 2 equals 6. Both of these, this top one actually means it's a point. X is 2, y is 6. Negative 2, 6. As we said, if you change the sign of x and you get the same y, then you have a function that's symmetric about the y-axis. So far, so good. We also call that function even. So if you plug in the different value, if the opposite of x, the change of sign, and you get the same y, then it's an even function. Even functions are symmetric about the y-axis. Okay, so let's look at another example. Is f of x even? Is f of x symmetric about the y-axis? Two questions. So what x did you choose? Okay, you pick 2. So we're going to check 2 and negative 2. So we plug those into the equation. 2 squared plus 2, negative 2 squared plus negative 2. 2 squared is 4. 4 plus 2 is 6. So f of 2 is 6. Negative 2 squared is 4. A positive and a negative becomes a negative. 4 minus 2 is 2. So is it even? No. Is it symmetric with the y-axis? Why? X's go inside the parentheses. That's X. Right. The Y's are different. The X's are opposites of each other, but the Y's are different. And these two answers will always be the same because it means the same thing. Symmetric about the y-axis is even. So they mean the same thing. So if something's symmetric about the y-axis, it's an even function. That's a note. Let's look at the other side now. F of x is symmetric about the x-axis if so if I had a point 3, 1, and I flip it about the x-axis, what is my new point? 3, negative 1. At 1, 4. And I flip it across the x-axis, what's my new point? Exactly, good job. 1, negative 4. If I gave you this point, what's the location of this point? Negative 2. If it's symmetric about the x-axis, what's my new point? Very good. Negative 4, positive 2. So a function is symmetric about the x-axis if the x values are the same and the y values are the same number but opposite signs. In other words, xy changes to x negative y. The x's stay the same, the y's change. So how do we test that? We have our function here. How would you test it? First off, pick a value x. Let's pick 2 since we're staying there. And plug it in there. So we have x is 2, y is 4. What if we change the value of y? What if I'm saying that the function -4 equals x plus 2? Will we get the same x? Solve for x. So x is equal to -6. So that function is not symmetric about the x-axis. But even though the y's are the same number, different signs, the x's are different. So the way you do this, you can either first off start off with a y value and work backwards, or you can do the way we did it. Choose an x. And plug it into the function. And solve it. Change the sign of the solution and solve for x. That's what we did here. First step, we chose a value for x, we plugged it in the equation, we got a solution. We changed that value, the solution. Remember, f of x is the same thing as y. So this is all equals to y. This is your y value, that's your answer. And now solve for x. If you get different values of x's, it's not symmetric. If you get different x values, then not symmetric. Because we're supposed to get the same x's for opposite y's. Let's do another example. Y squared equals X. Grab a sheet. Is this symmetric about the x-axis? How do you know? Mathematics is not guess. Would you swing at a ball blindfolded? Then you said the answer is no. So what would you do first? What's the first step? Okay, let's try that. Let's say x is equal to 4. Because remember, we're solving for y. What's going to happen? How do we get rid of the square here? Square root. We have to square root both sides. Whenever you square root something that's squared, you always put plus and minus in front of the answer. Whenever you square root a squared term, always place a plus and minus in front of the answer. Or the other side, I should say. So if I had x squared equals y and I square rooted it, those cancel, and I have a plus and minus square root of y. Bless you. Why do you think that is? Why do we put a plus and minus in front of there? Well, let's see here. If I put a 2 inside there and I square it, what do I get? I get a 4. If I put a negative 2 and I square it, what do I get? Also a 4. So whether it's positive or negative, I get the same answer. So that's why I have to take that in consideration. So I solve this one. I put a 4 in place of x. What's the square root of 4? So this means that y is equal to positive and negative 2. Because the x's are the same, the y's are the same, but opposite signs, it's symmetric about the x axis. So far, so good. So it's symmetric about the y-axis if the x change signs. It's symmetric about the y-axis if the y's change sign. How about f of x is symmetric about the origin if, what does that mean if it's symmetric about the origin? What quadrants is it going to, is it from going to where? 1 and 3. Very good. So it goes from 1 to 3, or it goes from 2 to 4, or vice versa. So inside quadrant 1, both numbers are positive. Inside quadrant 3, the signs of the numbers are what? They're both negative. In quadrant 2, negative, positive. And then quadrant 4. So what happens here if it's symmetric about the origin? If I had the number 4, 2, what would be its symmetric about the origin value? Yeah, it would be -4, -2. If I had 1, 6, what would be its symmetric value across the origin? Yeah, -1, -6. So what's happening there? But yeah, but what about the numbers? What's happening with the numbers? It's what? Yes, but now what about, you have to talk about both X and Y. It is, yeah, they are both, but what makes them opposite? What about the negatives? One term, both terms, what? If both X and Y values are the same, but have opposite signs. They have the same numbers, but opposite signs. For example, here's the easiest one I can think of. The graph of this one looks like this. When X is 2, Y is 2. So that's the point 2, 2. When X is -2, Y is -2. That's an example of a function that's symmetric about the origin. Can you think of any other ones? The answer is yes, if you memorize the library of function chart like I asked you guys 2 weeks ago. So what other function is symmetric about the origin? Yeah, but that's the same as that one. But you're right. That is because this graph here would look like this. And a different function. This is still linear. They're still linear. You mean a different type of function. What does x squared look like? It looks like a u. Is that across the origin? Across which axis? Yeah. The quadratic is symmetric about the y-axis. So the x changed from positive to negative. The y's remain the same. Look at your function chart. What other functions? I can think of two of them automatically. X cubed. Do a table. Give me a number. Let's, because we're going to cube it. It goes pretty quick. Let's try 1. What's 1 cubed? 1 times 1 times 1 is 1. That's what cube means. How about negative 1? Negative 1 times negative 1 times negative 1 is negative 1. At 0, it's 0. How about 2? 2 times 2 times 2 is 8. So at 2, it's 8. And at negative 2? So there's an example. XY, XY. Changes are both 1s, but one's positive, one's negative. 2, 8's positive, negative 2, 8, negative 2, negative 8. So that's an example of a function that's symmetric about the origin. Another function, the cube root function. When x is 1, y is 1. When x is negative 1, when x is 8, cube root of 8 is 2. Cube root of negative 8 is negative 2. It's just the opposite of this one. This function looks like this. Again, it's in your library of functions. There's another function. What function is that? It's a rational function. Rational, yeah, rational, 1 over x. Because the y values, the x values and the y values are the same, but they just change signs. They're symmetric about the origin. So functions symmetric about the origin have the same numbers but opposite signs. So xy changes to negative x, negative y. X negative y is the same thing, is symmetric about the origin, becomes what? If it's symmetric with the origin, I gave you x negative y. Negative x, positive y. If it's symmetric at the origin, the signs change to both x and y. Just the signs. If you think about it, this number is in quadrant 1. This number is in quadrant 1. This number is in quadrant 3. This number is in quadrant 4. This number is in quadrant 2. We just talked about that. What's really happening here is this. If a function is symmetric about the origin, it flips across the x-axis and then across the y-axis. That's what's happening. That's how come you, across the x-axis, you change the values of y. Across the y-axis, you change the values of x. So that's why you change both of them. Functions symmetric about the origin are odd functions. This is a note. So a function is even if what? What's that? What's that called? Symmetric about what? Right. Symmetric about the y-axis. You're right. You're right. That was right. It's just you put it in terms of math. What is it if it's odd? Symmetric about the what? Origin. If it's an even function and it's symmetric about the y-axis, what about their signs? What changes for even functions? Yeah, the y's. It changes signs of the y's only. Because it flips across the y-axis. No. The x's. Because the x's stay the same. If it's across the y, the x change signs. The y stay the same. And across the origin, what changes? Which one? Both. Because it's across the origin. So it goes from quadrant 1 to quadrant 3. So they both change. Yes, we've talked about proving something if it's odd, even, or if it's symmetric about something, whatever. Let me show you now a shortcut that if I just give you an equation, you don't have to do any work. You just look at the function and tell me if it's odd or even or neither. I'm going to give you about 6 or 7 equations. One. Here's the last 2. All right, let's look at these 8 questions and tell me if they're odd, even, or neither. Let's do the first one together, because I know you guys probably forgot how to do that. Let's for all, to make it easier for us, let's pick x equals 2 for all of these. So we have y equals 2 squared plus 2, and y equals negative 2 squared plus 2. Working this one out, we get what? 4 plus 2, we get 6. So we got 2 comma 6. Working this one, negative 2 squared is 4 plus 2 equals 6. So negative 2 equals. So what about this one? Odd, even, or neither? Even, because it's symmetric about the y-axis. The x's change signs. Everything else stays the same. How about this one? 2 plus 2. And if we put negative 2 in there, even, odd, or neither? Because the x's are opposite signs, but the y's are totally different. So these are neither. So keep on doing that to the rest of them.